Welcome to this YouTube channel, and I welcome you to another series. This is going to be pandas series, and we'll be exploring the pandas documentation just like we have been exploring the Python documentation. What we want to look at today is what kind of data does pandas handle? And if you think of it, there are a few ways to really access pandas. The way I'm going to use in this video would be through colab.research. So if you type Colab, if you open your whatever browser you use, open that browser and just type colab.research, and the first one should be this, or you choose this, whichever one will take you there. So if I choose this one, I'll have to choose either new notebook or open Colab. If I choose new notebook, it takes me directly to this place. And the good thing about it is that I can just start working immediately. So let's say I want to start using pandas. What I would do is to say import pandas as PD. And let me make this a little bit, let me zoom in. All right, so we do import pandas as PD. Now this is to load packages, to load the pandas package and to start working with it. And the community, that's the pandas community, agreed that the alias for pandas is going to be this PD. So loading pandas as PD is assumed the standard practice for all of the pandas documentation. And just let me show you what it looks like, how pandas represents the data table. For this, we have this. So this is the way pandas represents the data table. As you can see, this is DataFrame. This is a terminology that we'll be using very often. But a data frame is just a collection of, you can see, rows and columns, right? So let's say we want to store passenger data of the Titanic. And for a number of passengers, we know the name, which is a character, which are characters. We know the age, which are integers, and we know the sex, which is either male or female. And so we know that these are the things we have in the data. Let's head over to this place. We'll run this code, this chunk. And once we run that, let's see what we have. And once you see this tick mark, it means that we are good to go. And so you can just use shift return on Mac, or shift enter on Windows, on PC. So let's create our first data frame. pd.data_frame. Now we said we know the name, right? So let's say we know the name. One of the names of those people is, and by the way, I'm copying this from the pandas documentation site. And I'll leave a link to that, to this, to the pandas documentation below, in the description below. We have Mr. Owen Harris. Another person we have there is Alan, Mr. William Henry. and another is Bonnell Miss Elizabeth. Okay, now we're done with the name. The next thing we want to have is the age. And let's say that the ages of these people are 22, 35, and 58. We have comma. We have the third, which is, we know this is male. This is male. This is female. Can you imagine I'm spelling female wrongly? All right, so we have this. And for us to, let's run this. I'm just going to use the shift and return, shift enter. Let's print what we have here. We can just type out df. And once we type out df, we have this. As you can see, we have these names: Broad, Mr. Own, Harris, and all that. This is just to manually store data in a table. And so to manually store data in a table, you have to create a data frame. And when using a Python dictionary of lists, the dictionary keys will be used as the column headers, and the values in each list will be used as the columns of the data frame. And so if you think of it, look at the columns, look at this dictionary. This is the key here. Each key here is used as the header of the data frame, right? That's the column headers. But the value in each of these lists, the value in each of these lists is a column on its own. Look at, you can see that the name is under Broad. It's not like we have the name and then we have Broad here. So that's just this. So a data frame, to define it, is a two-dimensional data structure that can store data of different types, including characters, integers, floating point values. You have categorical data and more in columns. So all these data types can be defined in columns. When you think of this, just think of a spreadsheet. If you've used Microsoft Office Excel before, or LibreOffice, or any other spreadsheet packages that you use, or spreadsheet applications that you use. Or you think of this like a SQL table, or if you use R, you think of it like a data.frame in R. Now this table has 3 columns. As you can see, this is the first column, this is the first column, this is the second column, and then this is the third column. And each of these column, the column labels are respectively this name, the age, the sex. And it's very important to note this. The column name consists of textual data, with each value being a string. So when you look at this, all these names, they are of the string value, right? And if you look at age, for instance, they are numbers, and sex is also textual data. So if we think of this in a spreadsheet way of thinking, you would see that it's something more like this, where if you're in any of these spreadsheet packages, you can see that we have the name, we have the age, we have sex, right? And the names are here and the age here. And so this is just how you represent this kind of structure using pandas. And let's head over to Google Colabs. Each data frame, each column in the data frame is a series. So let me show you that again here. Each column in a data frame is a series. So when you think of the column, this is a series. And so let's say that we are just interested in working with the data in the age column. Let me say we are interested in working with the data in the age column. So how do we do that? We're interested in working with the data in the age column, just the age column. The way we can do that is by taking that data frame and then having this there. And let's run this to see what we have. You can see we have all the data in that column, 22, 35, 58. Now, if you do this, it's going to yell because it's case sensitive. By case sensitive, I mean that if the column name is age with an uppercase A, you shouldn't come here to access that column with a lowercase a, right? If it's an uppercase A there, it has to be an uppercase A here. I just thought I needed to mention that. So when selecting a single column of pandas data frame, the result is a pandas series. And for us to select that column, we use the column label in between square brackets, just as we did here. So the resulting type of data here is a series. And if you are familiar with Python dictionaries, the selection of a single column is very similar to the selection of a dictionary based on the key. So if you're familiar with Python dictionaries, you know that this is how you just make selections of the values of dictionaries based on a particular key, right? But you can also create a series from scratch. And so let's quickly do that. Let's say create series from scratch. So how can we achieve this? And let me bold in that. Okay, so we want to create a series from scratch. Now, a panda series does not have column labels because it's just a single column in any case. So it's just a single column of a data frame. And so there's no column label for it. How do we create series from scratch? We can do something like this. So let's say age is equal to pd.series. Just as we had pd.dataframe there, we have pd.series, and then we pass in the list of that series here, 22, 35, and then 58. And we have another argument here, which says that the name equal to age. And what that means is that this is just to indicate a way we can, I mean, when you think of this, just think of this as the name of the column, right? And these are the values associated with that column. So if I run this now, and I would print out ages here. Let's see what we have. As you can see, we have 0, 1, 2, 22, 35, 58, name, age, the data type is an integer, right? So let's see what you can do with data frame or with series. Let's say we want to know the, the maximum age of the passengers. Now, how would we go about this? I'm going to put this in, use Shift Enter, and let's say we want to know the maximum age. We can do this on the data frame by just selecting the age column and then applying a function called max. And the way we do that is, again, we've talked about how, we've talked about how to get that age, but then we can also run a function on it called max, and that gives us the maximum age of the passengers. Now, but let's also say that we want to do this on series. Recall that we have this ages variable, which is a series, right? The way we'll do that is by simply saying ages.max. And that gives us the same result. Maximum age to the series. Oh, let's say using the series. Okay. So as you can see, as illustrated by the max method, you can do things with a data frame or with the series. Now, pandas provides a lot of functionalities, and each of them each of them has a method you can apply to a data frame or series. And if you're wondering, methods are functions, and so you shouldn't forget to use parentheses. And that's why when we wrote out the max function here, we had to type out the parentheses, right? Now, let's say we want to get some basic statistics. We are interested in some basic statistics of sorry about my spelling. All right, basic statistics of the numerical data of the data table. How do we go about this? So it's simply by doing df.describe. And again, this is a function. When we run this, you can see it's going to tell you the count. And this is again under age, because age is the only numerical data. And so it's interesting to see this. And it's important to know that when you use the describe, we are interested, what you're doing is that you want to see the statistics, just some basic statistics of the numerical data that exists in that data table. And so in this case, we have age, we have only 3 of them. The mean age is 38.3, and the standard deviation is this. The mean is this. That's the least age, the lowest one. So the describe method just provides a quick overview of the numerical data in data frame. And because the name and the sex columns, because they are textual data, these are not taken into account by the describe method. It's very important to note that. And many pandas operations return a data frame or they return series. The describe method is an example of pandas operation that returns a series or data frame, and that depends on the output you have here. It depends on, I mean, for instance, we had just a single column here, right? So this is it. This is just a starting point, but similar to the spreadsheet software, pandas represents data, and this is just a recap. Pandas represents data as a table with columns and rows. And apart from the representation, also the data manipulations and calculations you would do in spreadsheet software, they are all supported by pandas. And so we'll continue to see in the next tutorial how we can read in and how we can write tabular data using pandas. And so what are the important things to remember? You import your package. Let me just go over this again. You import this pandas package, right? You import it as PD, and then you have a table of data that is stored as pandas data frame, which we had here. And each column in a data frame is called a series. And so when you think of this is a series, this is a series, this is a series. And so you can say that the combination of those series actually give you that data frame, because then you have rows and columns. And you can do things by applying a method to data frame or a series. So we'll continue in the next video, and let me know if you have any question or you have any suggestion. By the way, I forgot to mention, and if you don't have a Google account, I would encourage that you create a Google account, because that's how you use the Colab research. So I'm gonna call this pandas documentation tutorial. I know it's long. All right, so see you in the next video. Thank you for sticking with me, and I hope you had a nice time and do have a great time ahead of you. Thank you. Bye.